Hey guys, this is Mrs. Harbin, and we are going to continue today with Section 5. Today we're going to look at 5.7, which is all about the quadratic formula. Now before we do that, let's just take a quick review of what we've done so far this year and kind of how we have built on what we've started and we've progressed. So we started off at the very beginning with basic algebra. We just reviewed the order of operations and how to solve equations by combining like terms, getting the variable term by itself, and solving for that variable using inverse operations. So we just started off with some basic algebra. We then took that into linear relations, and in linear relations we were dealing with x and y terms that were just to the first power, and we would graph these linear equations and we would have to determine the slope of those lines and the intercept of those lines. And so we were looking at this equations which one graph just gave us this straight line. We also reviewed inequalities at that point and graphing inequalities. We then moved into solving systems, which was basically graphing two linear equations and finding out where those two linear equations intersected. And we did that by graphing, or by solving algebraically, or using substitution or elimination when it was going to be too difficult to graph these linear equations. We've then moved into quadratic equations. Now, linear equations had an x or a y just to the first power. And when we look at quadratic equations, we're now dealing with polynomials and variables, or x being raised to the second power. So quadratic equations have dealt with x squared terms for the first time. And what we've been trying to do is solve these quadratic equations. And we've done it a couple of different ways. And we've talked a little bit about how solving quadratic equations, it gives us what's called the zeros of the equation. When we go to graph these quadratic equations, which we will get into sooner rather than later, what we're basically finding is the points where this quadratic equation crosses the x-axis. And this is going to be really important when we start to graph these. So we're trying to find the zeros, and we've done that by factoring. We've done it by taking roots. We've looked at complex numbers and completing the square. And now we're going to look at another way that we can solve quadratic equations when we can't factor it or do any of those other methods, and that is the quadratic formula. So just as a quick review, our objective or our core biblical correlation for this unit comes from 1 Corinthians 12:12, which says that the body is a unit, though it is made up of many parts. So though all its parts are many, they form one body. So it is with Christ. And we've talked about how, just like in Christianity, we have all of these different pieces and parts that work together to accomplish one goal. And as we are continuing to go through algebra this year, we are learning about all of these different pieces and parts that will work together to help us solve problems, and we need to be able to solve problems so that we can take care of the world that God has given us. Specifically, when looking at quadratics, quadratics really are a mathematical model for motion, and they model motion in ways that help us help us protect people, which are image bearers of God. And again, when we get into graphing quadratic equations, you're really going to see how they model that motion. Our lesson objective for today is that you, the student, will solve quadratic equations using the quadratic formula. Again, we've looked at solving it with factoring, and we've looked at taking roots, and we've looked at completing the square. Now, this method, you can use this method all the time. You don't have to do any of the other methods if you don't want, but most people tend to use this kind of as a last resort. When factoring doesn't work, then we come to the quadratic formula. The quadratic formula is a formula that can be used to solve quadratic equations. Again, you don't have to do factoring at all. You could do this every single time if you wanted to, but again, most people prefer to factor first. It's a little bit easier, maybe a little more efficient than always using the quadratic equation, but it can be used to solve quadratic equations. It can be derived by completing the square to solve the general form of a quadratic equation. We looked at completing the square last class, and if we complete the square, Sorry, I accidentally hit the pause button there, so I'm not sure where I cut myself off, but we can complete the square of our general form of our quadratic equation to come up with our quadratic formula. This can be used to quickly solve any quadratic equation. So if you're stuck, you can't figure out how to factor something, you can't figure out how to complete the square, you can go to the quadratic formula. Right. This is just a quick step-by-step on how the quadratic formula was derived. You don't need to know this. This might be helpful for you who want to know why things are the way that they are, but you're not going to be asked to follow these steps or these procedures when you yourself are trying to solve quadratic equations. But this kind of just tells you how the quadratic formula came about. So it started with this general formula, general equation for a quadratic, ax squared plus bx plus c. And we're solving this equation for x. So we have ax squared plus bx equals negative c. We are then going to divide everything by a, and we get x squared plus b over a x equals negative c over a. That gives us x squared plus b over a x equals negative c over a. We're going to complete the square there, which is 1/2 of our b term, so 1/2 of b over a squared. We put that here, and whenever we do to one side, we also do to the other. So we add it to the other side as well. We then are going to finish our completing the square. We get x plus b over 2a squared equals 4ac over 4a squared plus b squared over 4a squared. We had to change this so that it had a common denominator so that we could combine those terms up here. Okay, combining our terms gives us this. Again, this is not something that you need to replicate, but if you want to know where the quadratic formula came from, okay, we then take the square root of those sides, and then we're trying to solve for x here. We're almost there, and we get x equals negative b plus or minus the square root of b squared minus 4ac over 2a. Now, you did need to write down all of the steps that we just saw. That's just a really quick look at where the quadratic formula came from. It came from completing the square of the general form of the quadratic equation. What you do need to know is this. And there are songs out there. We'll have a poster hanging up in the room. But whatever you need to do to commit this to memory, make sure you get this quadratic formula committed to memory. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So we can take that equation then and use that to solve quadratic equations. So in this general form, if ax squared plus bx plus c equals 0, and a, b, and c are real numbers, and a is not equal to 0. If a were equal to 0, we would have a linear equation. We would just have bx plus c. So in order to keep it a quadratic equation, a cannot be equal to 0. If that is true, then x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, there is a video linked here that I'm not going to click on right now that takes you to a song that will help you remember that quadratic formula. I will add that to our class playlist along with any other helpful videos I find about remembering the quadratic formula. So let's take a look at how to use the quadratic formula to solve a quadratic equation. We have x squared plus 4 equals 5x. Now the first thing that we need to do is get that into standard form, where all of our x terms are on one side and we have 0 on the other. So we're going to write that as x squared minus 5x plus 4 equals 0. That's in our standard ax squared plus bx plus c form. Once we have that set equal to 0, then we need to identify our a, our b, and our c. Our a is the 1 that's in front of the x squared, our b is negative 5, and our c is positive 4. Once we have those identified, we can plug those into our equation, our formula here. Negative b plus or minus square root of b squared minus 4ac all over 2a. Let's plug in those numbers. We have negative, and then plugging in a negative 5. Remember that when we use substitution, we want to use parentheses so that we don't drop our negative. So we're going to sub in a negative 5. Negative 5 squared minus 4 times 1 times 4 all over 2 times 1. From there, it's just following the steps of algebra to simplify. We get 5 plus or minus the square root of 25 minus 16 over 2, which simplifies to 5 plus or minus the square root of 9 over 2, which simplifies to 5 plus or minus 3 over 2, which simplifies to 5 plus 3 over 2, that's 8 over 2, which is 4, and 5 minus 3 is 2 over 2, which is 1. So again, just like when we factored and we got 2 possible values, we're going to solve here using the quadratic formula and get 2 possible values. Now just a quick sneak peek or reminder, a quadratic equation, when you graph it, linear equations, if you remember when you had just an x term, linear equations were straight lines. Quadratic equations are going to make this shape called a parabola. And it's either going to be a parabola going up or a parabola going down. And it's going to cross that x-axis at two different places. In this case, at 4 and at 1. It's going to cross the x-axis at those 2 points. You can see that this resembles or is a good graph for motion. Think about when you shoot something up into the air, like when you shoot a basketball, for example. It makes this nice parabola before it comes back down. Or if you try to take something that floats on water and you try to shove it underneath the water, it's going to come right back up following this kind of parabolic shape. And so parabolas do model motion for us. And the 4 and the 1 here are going to show us the 2 points there where that parabola is going to cross the x-axis. 2 places where it's going to cross the x-axis. Maybe something a little bit like that. Now, we could have solved that one by factoring. Let's go back really quickly. We could have solved this one by factoring. If you take a look at that, we know that 2 factors of 4, that when multiplied equal positive 4, but when added equal negative 5 are negative 4 and negative 1. We could have then set each of those equal to 0 and found out that x equals 4 or x equals 1. The same thing we found with the quadratic formula. So the quadratic formula works when you can factor if you would rather use that instead of factoring. Now, 4x squared plus 12x equals 11. This one is a little bit more difficult to factor. In fact, you might say, I can't factor this one. So we can use the quadratic formula to find both the exact solution and decimal approximations. Exact solutions are going to have the root symbol. Decimal approximations are when we actually punch that into our calculator and we round to the nearest hundredth of a place, for example. So let's solve this one. First, we need to put it into standard form and identify the A, B, and C terms. We have our A term is 4, B term is 12, our C term is negative 11. We will then plug those into our quadratic formula. Make sure that you're using parentheses when you substitute in. I would put parentheses here and here, so that we maintain the correct negatives and positives where they're supposed to be. And what we get is negative 12 plus or minus the square root of 144 over plus 176 all over 8. Let's simplify that a few more steps here, and we get negative 12 plus or minus the square root of 320 over 8. Now 320 is not a perfect square, but we can simplify it using prime factorization to simplify our radicals like we've already learned how to do, and that simplifies to 8 square root of 5. We can then take each of these here and divide each of these terms by 8. So negative 12 over 8 and 8 over 8 simplifies down to negative 3 over 2 and 2 over 2. We get negative 3 over 2 plus or minus the square root of 5. That is the exact solution. We leave that radical there. However, that's not very practical. If we're trying to graph something, we need to convert that to a decimal approximation. So plugging that into our calculator, we get plus square root of 5 and both minus the square root of 5. Remember, we have to do it both ways. We get approximately 0.74 and approximately negative 3.74. Now, I didn't review how to simplify that radical, simplify that square root of 320. So if you have forgotten how to simplify radicals, make sure you make a note on the notes that you're taking and ask me next class, how do we simplify those radicals again? And we will review that because you do need to know that for this quadratic formula. Remember that radicals are going to be your exact solution or your most common answer. Decimal approximations will round to the nearest hundred. It is very common to get radicals when you are using the quadratic formula if it wasn't something that was neatly factorable in the first place. All right, let's take a look at this example. X squared minus 10x plus 29. Let's identify our A, B, and C and plug those into the formula. Pause the video, try to solve this one on your own, and come back and check your work. Right, plugging that in, we get these numbers. Again, be sure to use parentheses when you are substituting so that you don't drop any of those important negative signs. I'm going to go through these quickly. Pause the video if you need to see that, but I'm going to stop when we get to right here because you'll see that we have a square root of negative 16. Remember, we can't take the square root of a negative number. So to denote that, we're going to take the square root of 16, which is 4, here, and then the square root of negative 1, which we'll translate there as an I. So we have 10 plus or minus 4i over 2. We can simplify that, 5 plus or minus 2i, by breaking